Alright, so starting with section 2, main idea, atom has a nucleus in the middle. The nucleus contains protons and neutrons, and then the electrons are outside of the nucleus and move around it. The main thing I'm going to want you guys to get out of this section, I do want you to know some of the scientists. I don't need you to know years, but I need to know which scientist found electrons and how did he do it. What scientist found protons and how did he do it. So other things, what is an atom? How can subatomic particles be distinguished in charge and mass? So I want to know what is the charge of a proton, what's the charge of an electron, and where are they located? Are they in the nucleus? Are they outside of the nucleus? Where are they at? There's the vocab. So getting started. An atom, first vocab word, smallest particle of an element that has all the properties of that element. So if I have tin, if I have one tin atom, that's the smallest piece or part of tin I can have. I can't make it any smaller than an atom. And the instrument that we have now, so we actually can see individual atoms, is called a scanning tunneling microscope. And those are expensive, and we do not have one, so we won't be using one, but those are, just so you know, there are microscopes where we can see atoms. So, first group, the electron is a subatomic particle. When electric charge is applied, a ray of radiation is going to be shot through the cathode to the anode. It's called a cathode ray. So what I want you to know is that electrons were found using a cathode ray tube, and electrons carry a negative charge. So this is the tool that they used to find an electron that we now know has a negative charge. J.J. Thomson is the scientist that used the cathode ray tube. And he looked at magnetic fields, he looked at electric fields, he used his tube, and then he compared it to stuff that he already knew. Another thing that he found out is that the mass of an electron was way less than a hydrogen atom, which is the smallest atom there is. So basically he found out that the mass of an electron is super tiny. So even though everything is small, an electron has almost no mass. Millikan also used, basically it's called an oil drop, or an oil drop apparatus. He helped to determine the charge of an electron. So here he shot radiation through. These electrons then were sent from the negatively charged plate. Millikan, probably not quite as important as Thomson. Millikan, probably a little bit more with the exact charge. So, charges change in very, very small numbers. I don't really care that you know this exact number. What I do want you to know is that we take this number as a standard and we assign an electron a charge of -1. So basically it's almost like a ratio. This is the actual charge and we're giving it a charge of -1. So with the electron's charge found and its mass found, we could actually calculate the mass in grams, 1 over 1,840, which is very, very tiny. So when we talk about the mass of the atom, we neglect that number because it is so tiny. We look at the mass that's only found in the nucleus. So we're saying that the electron is negative, however, all matter is neutral. If it were not neutral, you would get shocks on everything that you touch. You typically only get shocks if you rub your feet or maybe you're wearing something staticky. And what happens then is those electrons get rubbed and then they go to one place or another and they create a charge. But typically all matter is neutral, and you know that because you don't get shocks. If electrons are negative, then how is everything neutral? So the model that J.J. Thomson uses, it's called the plum pudding model. If you do not eat plum pudding, you might call it the chocolate chip cookie model. Basically, he thought that electrons were negative and they were spread throughout matter, and then it was surrounded by something that had a positive charge. So the positive charge of the pudding or the cookie dough neutralized the negative charge of the scattered plums or the scattered chocolate chips, however you want to look at it. This is now an incorrect model, but this is the first one that was basically sent out to the public. So then, Ernest Rutherford, 1911, studied how positively charged particles interacted with matter. So here, he's still thinking that we have this plum pudding model, and I'll get to the experiment that he used, but basically it's called the gold foil experiment, and he was shooting these alpha particles through a material, and he expected that they would be altered whenever they hit an electron. So when he shot these rays through, he expected that there would be some changes. So here's kind of his setup. So he had gold foil in the middle, and then he shot beams of positively charged particles that went through that gold foil. And what he found is that most of the particles went right through the gold foil. They didn't get deflected. Most of them went straight through. There were some, so here's one that's deflected a little bit. Here's one that's deflected a lot. So there were some particles that were deflected, but most of them went right through it. And here, as this screen basically lights up when those particles hit it, so that's how he could see where it was hitting the outside. That's how he detected where the radiation ended up. So, quickly, here is an example of the gold foil experiment.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there. The scientists concluded that atoms must be mostly empty space, and that because some particles are deflected, there must be a small positively charged central mass, which they called the nucleus.
So Rutherford...
The nucleus of an atom was first discovered when a beam of positively...
So Rutherford is the scientist that used this experiment. And what they found, basically what was found from this experiment, was that there's a positive nucleus. So when an electron would hit that nucleus, it would be deflected one way or another. Most of them went through, so they decided most of the atom was simply empty space with nothing in it. So what happened, okay, mostly empty space, All of the positive part was found in the nucleus, which is the same as a cell. You know, the nucleus is kind of towards the center part of it. Electrons are held to this because positive and negatives attract, so that holds the atom together. And then what happened when something would hit, when this positive particle would hit the nucleus, then it would bounce off. If it hit right in the middle, it bounced back. But most of an atom is the electron cloud, or empty. It's not the nucleus. So most of those particles went right through and were not stopped by anything. An electron is too small to affect the path of the alpha radiation. So Rutherford's responsible for finding the nucleus, and he included protons in that nucleus. And protons are now what have the positive charge. Electrons are negative, they're on the outside. Protons are positive, they're in the nucleus. And then James Chadwick is responsible for finding neutrons, which are also in the nucleus. Why would neutrons be found last? They don't have a charge. So they are not attracted, they don't deflect. Because they don't have a charge, they aren't as easy to find. They were the last subatomic particles found. And the reason they were found is because they do have a mass that adds to the atom. And that helped them be discovered. So now we know in the nucleus we have protons that are positive. We have neutrons that are neutral, have no charge whatsoever. And then outside we have electrons that have a negative charge that are found in this electron cloud that surround the nucleus. So atoms are considered still to have somewhat of a spherical shape. They're mostly empty space. Make sure that you know that. That empty space has the electrons, and then the nucleus is in the center. And one more short one.
If you could see an individual atom, it would appear to be a solid sphere. But if you could take a closer look, you would see that an atom is made up of a few particles and a lot of empty space. The outer part of an atom consists of negatively charged particles called electrons.
That's the nucleus, right?
Electrons move in energy levels around a central group of particles called a nucleus. The nucleus is made up of particles called neutrons that have no charge, and protons that are positively charged. The number of protons in an atom tells you what element it is. Almost all the mass of an atom is in its nucleus. The total number of particles found there is the mass number. If a neutron is added to an atom of the same element but with a different mass forms. Atoms with the same number of protons but different numbers of neutrons are called isotopes. However, if the number of protons is changed, an atom of a different element is formed.
And that is important, and we'll talk a lot about that next section. If the protons change, you have an entirely new element. If the neutrons change, it just changes the mass. So the number of protons is probably the most important part of your atom because it tells you specifically what atom it is. So, inside of the nucleus, they have determined that protons and neutrons are actually made up of smaller yet particles called quarks. Scientists do not yet understand the behavior of quarks. And there's not a lot that I can talk about with it. However, the underground lab out west studies quarks and small particles like that. And that's about it there. So a quark is a very, very tiny particle. Table, I'll have you guys do that. And then here's your last slide. Make sure you know all the information that's on